Hello everyone. Today our topic is K nearest neighbor, that is KNN. So what do you mean by KNN? It is just simple a supervised mechanism that is used for both what classification and regression process. Classification, we get the outputs into two major terms, that is classification either on the regression, that is in the yes no format. Okay, so what does k mean sorry, what is knn? It is the simplest. The k means the closest neighbor to a new point. Okay, it is just what the closest neighbor to a new point. Okay, and using a majority vote for classification and average we use for what, to find the regression. How it works: first of all we have to select the k number of k's of the neighbors, then we have to calculate what, equalized distance. Now what do you mean by equalized distance? So equalized distance is what, it is just defined as what, it is the straight line, a distance between 2 points in a plane. Okay, what it is, just the distance between a straight line in a plane, and it is calculated as on this formula, like xj minus xi. Shortest path you work directly one point to the another. Okay, this equal light distance term. Like in this you can see it is a new point, and it, which point is like nearest, if we take this point as nearest, so just the shortest we will be calculating by taking to this point distance. Okay, so it is just simple as that to calculate the equalized distance. And then next what we have to see, take the k nearest neighbor per the calculated equalized distance. We will taking the k and then calculate the equalized distance. Then among these k neighbors, we have to count the number of data points in each category and then assign new data point to that category. Okay, which is the number of neighbors is maximum. Then let us see how we will determine the k values. How we will be determining the k values by choosing k in the KNN algorithm, which is very much essential for achieving the good model performance. And then if the k is too small, then what it will be, the model will rely on just few neighbors to make the decision, and then which will lead to a high error rate on the unseen data, and this will case as what, overfitting. What is overfitting? Overfitting is that when our model is working so well during the training time, but it lacks during what, testing time. Okay, and which will result in what, the boundaries, decision boundaries, and it will become very sharp and inflexible. Okay, you can see in this graph we have fits of what, like it is underfitting, and the green one is good fitting, and the red one is what, overfit. What is underfit? Underfit is like when our model is not working good in training also, and eventually not in testing time also. Okay, and what is good fit? What is good fit? Good fit is generally like when our model is working good in both, like average on a good purpose in both the terms, in training time also and in texting time also. Now what it is given, that if a k is too large, if our the value of k is too large, then the decision models will be smooth and it will lose. Okay, and if the k increases, that can classify what, misclassify underfitting. We know what underfitting is. So if will not like if there is no rule to choose the best k, then what we will do, we will just choose k as an odd number, and we will just put it in this equation to find the k, that is k equals to square root of number of training data points. Okay, now we have some distances matrix that are used in knn algorithms. What is that? It is to identify the nearest neighbor we use for below distances matrices. Okay, what first it is, Euclidean distance. What it does to mean it is in the straight line, that is the distance between the 2 points in a plane or a space. Okay, just a distance between two plane or a space, that is what this in the shortest part, that is what Euclidean distance. How we calculate it, like distance equals to x comma xi, and the root of summation of x minus to the whole square. Okay, then maintenance distance. What does this means? It is just that if we move in a horizontal and a vertical line like a grid or a city street, okay, in a simple term, so what is like if we move along a horizontal or in a vertical lines in a grid form, so that is known as what Manhattan distance, and we calculate it how in this form, d of x by summation of not xi minus yi. Okay, then Minkowski distance is what? Minkowski distance is like it is the combination of our both Euclidean and Manhattan distance. Okay, how we calculate it? Like d of x o y where summation of x minus p root of then a whole what power of 1 upon p. When we will be putting the p value is equals to 2, then it will be count as what Euclidean distance. Otherwise, if we will be putting p equals to 1, that will be what our Manhattan distance. Here are some of the applications of KNN. What are they? That it can be used in healthcare sectors also, like we can detect what we can detect tumors, and even we can do the risk prediction in the healthcare care sector, that how much amount of risk is suffering in a cancer or like that. Okay, the next for in the finance sector for assisting risk assessment of risk, it can be used in bankrupt prediction, it can be used for image recognition, we can eventually use this like for identifying objects or patterns, for recommendation systems like for suggesting contents and products in these types of, like in a customer behavior analysis also, they predicting also our purchase behavior we can use for this criteria. Now what are the advantages are that it is simple and very easy to understand, and like it is very easy for learning algorithm, that we don't need to create any beforehand or any structure, it is just like stores the data sets and make prediction on demand. It is even and it is also what versatile because it can be implemented on both the aspects like classification and regression. Okay, now what are the disadvantages are like it is highly computation cost because it hold large data sets and computing distance to all the points during prediction that can lead to be slow. Okay, and it also what gain and stores the entire data sets in the memory, which is which is impractical for the large number of data sets. Okay, and it is also inappropriate for the values of k because it leads to what overfitting and underfitting. And the another one is also that the number of features increase, so the distance calculation becomes what meaningful and that can reduce the accuracy. Okay, thank you.